So now today we are going to start another question related to our CBSE board previous year questions. Okay. So the question is in series LCR circuit with L, that is a inductance 5 Henry, capacitance 80 microfarad, resistance 40 ohm connected to a variable frequency 240 source voltage source. Calculate means what we have to calculate. We have to calculate angular frequency which drives the circuits at resonance, the current at resonating frequency, and the RMS potential drop across the capacitor. Okay, so let us write the given sections. Okay, what are the given sections here? The L, H, L, C, and R is given. Okay, means that is L is given. This is 5 Henry. Here the capacitance is given. It is 80 microfarad. So we can convert into a farad. 80 into 10 to the power minus 6 farad. Okay. And the last what we have, R is equals to 40 ohm. Okay. If we draw a circuit for that series LCR, okay, our circuit will like this. This is an inductor, this is a capacitor, and here it is the resistor, and these all are connected with an AC source having a voltage of 240 volts. So this is the given section which we have. Okay, so the first part, what we have to calculate, we have to calculate the angular frequency of the source which drives the circuit at resonance. We have to calculate what? Angular frequency of the source. So let's start. Firstly we have to understood that what is the resonance sections. Okay, so resonance is what? Resonance is the condition where XL is equals to XC. This XL is what and XC is what? XL is the inductive reactance. XL is inductive reactance. Okay, and XC is capacitive reactance. Capacitive reactance. Okay, so now the condition, resonance condition is XL is equals to XC, and we have to find the angular frequency. So now we know that XL is equals to L omega and XC is equals to 1 upon C omega. Okay, so now omega into omega, which is equals to 1 by LC, we have omega square equals to 1 by LC. So what will be the value of omega then? 1 by root upon LC. Okay, if we put the value, of L and C, what we get, the L is 5 into the C is 80 into 10 to the power minus 6 foot. Okay, so now the next part is omega is equals to 1 by root upon 400 to 10 to the power minus 6. Here omega is equals to 1 by 400 root is 20 into 10 to the power minus 3. So omega is equals to 10 to the power 3 by 20. When we will solve this, this is 1000, this is 20, 0 get cancelled, and this will be 50. So value for the angular frequency is 50 radian per second. So this is the first, this we have the first answer. Okay, so this we have the first part. So the first part has been completed. Now come to the second section. Second section is told that we have to find the current at the resonant frequency. Means what? We have to find current at resonance. Okay, so let's start the second section. This one is the A part. Okay, so this was in the second part, B. So current at resonant, current at resonant. Okay, so we know that at at resonant, what we have, XL is equals to XC. Okay, but the impedance that we have, Z, which is equals to R square plus XL minus XC ka whole square. This is the formula for the impedance of the circuit, and when this XL is equals to XC, this XL equals to XC, we have the value of Z equals to root upon R square, which is equals to R. Means the value of Z is equal to R. Okay. So now what we have to find, the R value is 40 ohm. I think just look at that question. Yes, the R is 40 ohm. Okay, we have R is 40. The value of Z, which is equals to R, equals to 40. Okay, 40 ohm. So now what we have to find, the current, that RMS value which we have, RMS is equals to VRMS by Z. So VRMS we have 240, and we have Z equals to R, which is equals to 40. 0 get cancel. Answer is 6 ampere. The second part also came. Okay, now come to the third part. The third section is the the RMS potential drop across the capacitor at resonance. RMS potential drop, we have to find out the RMS potential drop. Okay, so let's start with the RMS potential drop. So this is for question number C. RMS potential drop at C means we have to find VRMS for capacitance value. So VRMS is equals to, we know that IRMS into XC. From where this formula come, we know that V is equals to IR, but this is the condition for the resonant part, but it's told that कि मुझे जो चाहिए वो कैपेसिटेंस के अक्रॉस चाहिए. किसके अक्रॉस चाहिए? कैपेसिटेंस के अक्रॉस का वोल्टेज ड्रॉप. मतलब this R becomes XC, so that's why VRMS is equals to IRMS into XC. So we will put the value of IRMS. So IRMS we get 6 ampere into, and the value of XC is what? 1 by C omega. So we'll put the value of C, 1 by C omega. What is the value of C here? The value of C is 80 into 10 to the power minus 6. So we can write 80 into 10 to the power minus 6, and omega value we get, what with the value of omega we get 50. So we can put the value 50. So what the value of vrms is equals to, during calculation value we will get 1500 volt. Okay, so this can be done by very easiest way. Okay, so just look this question once again. We have to find out these three questions. Okay, so individually we have find this one is the a section, this one is the a section, this one we have the b section, and this one we have the c section. Okay, while we completing these two, now we have to make this diagram also, because this diagram is also important, and this question comes in cbse to cbse 12. Okay, it means that is 2012 it comes. Okay, so for more videos, like our channel, subscribe our channel. Thank you.